Okay, so to help make sense of the TMN models, I'm going to present an example, but the example needs to have topology to talk to first. So here we see a number of nodes, connected quantum nodes that are connected to a variety of operator networks. We have the labels Alice, Bob, Charlie, and Dave, but these don't necessarily represent people. In fact, given the size of the equipment, they can't really represent people, more as things. In this diagram, you can see that different of these quantum nodes have both quantum and classical links into their operator networks. And sometimes they have many more quantum and classical links than they may be needed. Notice the satellite has links pointing into two different operator networks, and so it could potentially act as like a repeater. This diagram describes potentially more than one operator network, but today most of the deployments are a single operator network. And in fact, these nodes may not be considered to be outside of the operator network, but actually inside the operator network. But for purpose of depiction, showing them outside makes sense. What's exciting to me is to think about the administration of scale. If we think about, a number of years ago, a data center or the computers that would run, a large mainframe computer would take up the space of a room or a building. And nowadays, the same compute power is available in your pocket. Similarly, today, each of these quantum nodes need to have a certain amount of quantum equipment in them. There'd be, for instance, an optical table or two containing things like measure models and detectors and timing modules. They may even have lasers and repair modules or polarization correctors. There's a lot of equipment that exists, and you need to have a room or two in order to have all the equipment necessary to implement the functions to be part of a quantum network. However, one might imagine in the future there could be all that equipment could be miniaturized down to the size of something that could fit onto a smartwatch. And what's truly interesting about this is that maybe it could help solve the identity problem. How do we know that Alice is really Alice or Charlie is really Charlie? Well, you're actually wearing a device on your personal self, then there may be some ability for using a quantum identity to know for sure that you're speaking with a certain person. Okay, now for the example. First, we'll talk about configuration. At a high level, there's a user, and they say, I want a full mesh VPN between Alice, Bob, Charlie, and Dave, using links having top secret level security, sub-second latency, and 1 kilobyte per second throughput. And here, let's pretend top level security means that needs to use quantum cryptography. This request is received by the SMS layer, which generates 6 point-to-point links having said link properties, and sends those link configurations to the NMSs using NMS-specific APIs. The NMSs initiate a network-wide commit, atomic commit. So remember before the need for updates to be atomic and transactional, but also either all the devices need to be updated or none of the devices need to be updated. So it needs to initiate that atomic commit first. Then for each of the links, it optimizes the placement of the link considering the network topology and current available capacity and amongst other metrics. It then converts those link abstractions into EMS-specific node configurations and send those node configurations to the EMSs using the EMS-specific APIs. And lastly, the EMSs would, for each node, send the node configuration to the network element using the network element specific API. So in this example, we see how the configuration attribute is bisecting or going through the different layers, and that has different meaning at each of those layers. Next, we'll talk about faults. Going bottom up, we have a backhoe which snaps a device's uplink quantum fiber cable. This is a disaster, having one of your cables interrupted. There's other disasters though. There's human error, for instance, pressing the wrong button, or technical errors such as Y2K, environmental issues such as fire, flood, meteor, hurricane, earthquake, or even malicious intent like sabotage. But in any case, something's happened to disrupt the uplink quantum fiber cable, and at that point, the network element just detects that event and sends an alert saying interface down, which is received by the element management system, which converts that alert into a higher level alert saying Alice's device is down, or the interface on Alice's device is down, which is then received by the NMS layer, realizing that if Alice's device is down, then the various links that connects to that device must also be down. And so it can generate 3 alerts saying that Alice's link to Bob is down, Alice's link to Charlie is down, and Alice's link to Dave is down, which is then received by the SMS layer, which can consume it and internalize it as meaning that the full mesh VPN is degraded. Okay, so what do we do about this? Which leads us to the topic of self-healing networks. When there's a service, such as a full mesh VPN, it represents an intent that is to be maintained. Failure to maintain that intent may violate an SLA that the operator has with its customers. Production network architectures can eliminate single points of failure using redundant hardware, but over-provisioning resources can lead to underutilization. Another strategy to minimize mean time to recovery, or MTTR, is using closed-loop automation, which automatically bridges the gap between data to insight and insight to data. So in here, the data is that the link is down, the insight is that the service is down, the desire is to reinstate the service, and the action is to push new configuration to the network in order to bring the service back up. When just talking about SLAs, many times people refer to the class of service or how many nines it contains. People many times refer to the 5 nines of availability, which means that it's up 99.999% of the time, or said another way, it only has 5.26 minutes of unscheduled downtime per year. There is a contractual difference between scheduled and unscheduled downtime. But even scheduled downtime can be minimized using techniques such as in-service software upgrade. Lastly, there's closed-loop automation. Addressing the issues presented a couple slides back, if there were a redundant quantum fiber uplink cable, it would have enabled the SMS to dynamically reprovision the 3 downed links in seconds. More generally, closed-loop automation continuously addresses real-time network conditions, traffic demands, and resource availability to determine the best placement of traffic and optimal service quality and resource utilization, according to operator-defined policies. So essentially, it moves from being reactive to proactive. Proper rebalancing of services sometimes entails holistic analysis, as no simple ordering will achieve the optimal outcome. By this, I mean, for instance, in the previous slide, I discussed how it would generate the placement of a link based on current network topology and available capacity. But those links would be, the placement of those links would be sequenced in a certain order, and one order might present a more optimal outcome, global outcome, than a different order. This then leads us into AI-driven automation. On the left is a nice-looking network operations center where trained specialists monitor screens presenting data of the current performance of the network, and then issuing commands to update the network as needed. Still, it takes time between their discovering the issue and reacting to it. And so there's this push to use artificial intelligence to close that in order for it to occur instantaneously.